Okay, in this particular video, we'll be discussing control field of SDLC frame. The control field of SDLC frame identifies first the type of the frame, so you'll come to know what kind of frame it is. Carries acknowledgements, sequence number, unnumbered commands and responses, and the pole and final bit. And it is very simple. This question comes for 6 to 8 marks. Explain control field of SDLC. Okay. First thing, it is of 8 bits. Okay, usually it is made up of 8 bits. Now the control field is there in iframe, it is there in supervisory frame, as well as it is in unnumbered frame. So what we'll do is that we'll discuss this with all these three control fields of all these three frames separately. Okay. Now how do you understand that it is a control field of an iframe? If the first bit is 0, over here, if it is a 0, we understand that this control field is of the iframe, that it is the I information frame. Okay, so the first field, if it is 0, it is the iframe. If the next 3 bits, this is this, now these 3 next bits, they will specify the sequence number of the iframe. Now all those iframes are given a sequence number, and these 3 bits are used to identify the sequence number or the sequence number of the iframe. Okay, now here 3-bit numbering scheme is used. Okay, we also have 7-bit numbering that we'll see later on. So if it is 3-bit numbering system, this bit, this bit, and this bit will identify. It will tell the sequence number of the I field. Now next is something called as P/F bit. Okay, now this is also called as pole/final bit. Now this is very important. We'll again discuss in detail later on when we will be learning the actual operation of this protocol. Okay, now for now what I will try to tell you all is that it is stands for pole and final bit. Okay, it is called it is either P or F, both are not there. Okay, so it is called the P bit when the frame is a command. So if the frame is a command, it is called as the P bit. That is the frame that is which is been sent by a primary station. Okay, and it is F bit. It is a F bit. Okay, when the frame is a response. So when it is a response, that is the frame is been sent by a secondary station. So it is either a P bit or a F bit. Okay, if it is a command, it is a P bit, and if it is a response, it is the F bit. Now as we have discussed that in sliding window there is something called as piggybacking. So when there is piggybacking, it carries two kinds of two things. So one is the data and one is the acknowledgement of the received frame. Now here in these 3 bits, it will have the acknowledgement number or the RR number of the frames that it has received. It is very simple. So control field of the iframe, it always starts with 0. If it is 0, it is a iframe, control field of the iframe. Next bit I will tell the sequence number of the iframe, and then pole and final bit it will tell whether it is a command or whether it is a response, and who has sent it, whether it has been sent by a primary station or it has been sent by a secondary station. And this last 3 bits, it will specify the sequence number of the RR acknowledgement. Okay. Next, okay, control field of the S frame. Now, if first 2 bits, okay, in this particular field is 1 and 0, so if it starts with 1 and 0, okay, this particular control field is of your supervisory frame. Okay, so in your I frame, it was, if it was starting with 0, it was of I frame. Yeah, in case of a supervisory frame, if it starts with 1 and 0, it is of control field of the supervisory frame. Okay, now this is very simple. Okay, now these 2 bits will tell the receiver what kind of acknowledgement it is carrying. Okay, because supervisory frame always carries the acknowledgement. So here this is a bit pattern. If it is 0 0, it is carrying receive ready. So these 2 particular bits, it is only telling what kind of frames, what kind of acknowledgement it is carrying. So whether it is receive ready, okay, if it is 0 1, it is reject. If it is 1 1, it is selective reject, and if it is 1 0, it is received not ready, that is RNR acknowledgement. Okay, the PF is the same as what we discussed previously. Okay, and what will be this now? This will be the sequence number of whatever acknowledgement it is carrying. So suppose say this was 0 0. So what will be this? This will be so 0 0 means it is a receive ready frame, which is over here. So this will be the actual sequence number of the receive ready acknowledgement. Okay, so it is very simple. Next is controlled field of U frame. Now, if first two bits are 1 1, it is controlled field of the U frame. Again, I will make a small revision. If it is 0, if it starts with 0, it is control field of your I frame. If it starts with 1 0, it is control field of your S frame. If it is 1 1, then it is control field of your U frame. Okay, and this M which is there 1 2 3 4 5, they are the modifier bits. Okay, now there is one big table that I don't expect students to remember, but all these things, can't by heart all these things. But it will be good if you can remember at least 1 or 2. Okay, now these things are very important actually, but I don't know how this bit pattern now students should learn. Okay, now if you ask me, I used to remember this. I used to have some patterns. Okay, it is like 11 1 and 11 10, something like that, and somehow I could write this. Now if you see this now, there are so many modes. No, we have normal response mode, asynchronous response mode. To set them, we have something called as set normal response mode, set asynchronous response mode, and then set asynchronous balance mode, and then to disconnect the link, we have something called as disconnect. Okay, now how I used to remember is that I used to remember some pattern 11 1. So 11 1 means what now? It starts with 11 here, 1 and 1, and the end is 1. So it is 11 and 1, and it is sent from the, it is a command. Okay, so it is P over here. So somehow I used to remember this pattern to write for exam. So it is 1 1 and it ends with 1. Okay, now if you see your disconnect, it is like 11 10. Okay, so it starts with 11 and then ends with 10. So this is how I used to remember. So you might have your own ways to remember. Okay, so when we actually learn the protocol operation, you will understand what are the why these things are used and what is the significance of all these things. Okay, for now just to remember is these M bits are called as modifier bits, and whatever values it is carrying, it will specify a particular mode. Okay, or it will specify the command. Okay, for those particular modes. Okay, it's not a difficult thing. Next, I guess I have not made a slide for this, but there is one very important, very important topic called as transparency. Okay, in SDLC. Now this question is asked, what is discuss transparency in biasing as well as in SDLC. There we had discussed about DLE, DLE and all, and we have seen how transparency is maintained. Now in this particular case, we'll discuss now how transparency is maintained. For that, we'll just take one SDLC frame. Okay, now what does transparency mean? Now see, it starts with the flag. Okay, it has a unique big pattern, that is, it will start with 0 and end with 0, and all middle bits are 1. Okay, finally this flag will tell what now the receiver, that a frame is coming, or the frame has come. Okay, and there is one more flag at the end of the frame. What this flag will tell? That it is the end of the frame. Finally, this flag is actually made up of some bit pattern now. Okay, and that is 0 1 1 1 1 1 1 and 0. So even these bit patterns are read by the receiver, you will understand the frame is over. What if this bit pattern comes somewhere over here? If it comes somewhere over here, what will the receiver will do is that it will get confused. Okay, it will assume that the frame is over and the frame will have error over here. Why? Because the information field or the control or some other field will have a bit pattern that is matching with the flag. Okay, now how do you avoid this? Okay, how do you avoid this situation? Now what they do is that, now suppose say anywhere in this field from here, from address control information FCS, we'll talk about this information only, better it becomes simple. Suppose say if it is having a bit pattern which starts with 0, okay, now actually flag is what now, 0, 6 ones and ends with 0, total 8 bits. Okay, suppose in this information field, if it starts with 0 and it has 5 continuous ones, the sender will never take a risk of sending 6 continuous ones. Okay, so what it does is that if it starts with 0 and 5, if it is having 5 continuous ones after that 0, what it will do is that it will purposely stuff a 0 after 5 continuous ones, and it will never ever it will ensure that we will not have that the unique bit pattern of flag in whichever field it is. So it is like, first if it is 0 and if it is having 5 continuous ones, so compulsory what it will do, after 5 continuous ones it will stuff a 0 there. So this combination will is not a flag okay, so it will add one extra 0 there, and then it will send whatever bits it has after that. Okay, it can be a 1 and a 0 also. Okay, so it has actually stuff extra 0 after 5 continuous ones. Okay, this technique is called as zero stuffing. Okay, it doesn't allow the any field to have same bit patterns which are matching with the flag. Okay, now how does the receiver understand that it is zero stuffing? Okay, or there was transparency there at the sending side. Okay, so when the receiver receives this bit pattern, that it receives 1, it receives a 0 followed by 5 1, and then if there is a 0 after those 5 1, so what it will do is that at the receiver it will remove that 0 and then it will adjust the remaining data. Okay, this is how the receiver and in HDLC complete transparency is taken care of. Okay, so with this we'll end this video. Okay, thank you very much.